Hey everyone, welcome to Rev Games Academy. In this video, we are going to dive deep into one of the most essential components in Unity, transformations. We will break down the core concepts of position, rotation, and scale, which are crucial for controlling every game object in Unity. Let's get started. The transform component is the backbone of every game object in Unity, defining its spatial relationship within the game world or relative to its parent. Let's break this down into three essential aspects: position, rotation, and scale. Let's take a closer look at position. In Unity, position refers to an object's location in the scene and can be understood through two perspectives: world position and local position. World position defines where an object is situated in the overall game world, while local position specifies its position relative to its parent object in a hierarchical structure. When an object is part of a parent-child hierarchy, its local position is calculated based on its parent's transform, whereas world position remains independent of the hierarchy. Managing an object's position is fundamental to game development, enabling precise placement and movement. You can modify an object's position in several ways. One way is to manually change the position values in the inspector window by typing the desired coordinates or by moving the cursor near the position you need to change. This approach is helpful for static or visually guided adjustments. Alternatively, for dynamic or programmatic changes, you can use scripting to update an object's position during game. In this case, the transform.position property is used to directly set the object's world position, giving you greater flexibility and control. This method allows you to set precise positions, calculate movements, or create smooth transitions based on game logic. Here's an example of how to achieve this through scripting in Unity. Create a script and attach it to the game object whose position you want to change, and start running the game to observe the position change. Next, let's dive into rotation in Unity. Rotation determines an object's orientation in the scene and is controlled using quaternions or Euler angles. Euler angles are more intuitive for developers, representing rotation in degrees around the X, Y, and Z axes. Quaternions, on the other hand, are more robust and better suited for smooth rotations, avoiding such problems. Understanding rotation is crucial for tasks such as animating objects, orienting cameras, or handling player-controlled movements in a 3D space. Rotation can be set or adjusted manually in the inspector by moving the cursor near the position you need to change, or dynamically through scripting. Unity provides methods like transform.rotate for relative rotation and transform.rotation or transform.local rotation values, or for setting absolute world or local rotation values. In Unity, scale refers to the size of an object in the scene represented along the X, Y, and Z axes. It is a crucial property for altering the proportions of game objects, whether it's enlarging characters, resizing environmental elements, or creating dynamic effects. Scaling can be applied uniformly or non-uniformly and is typically done through the transform.local scale property in Unity's transform component. This property allows for easy adjustments directly in the inspector or through scripting. While scaling, developers should consider how changes might affect an object's behavior, particularly in physics, as scaling can influence colliders and rigid bodies, potentially causing unexpected interactions. Now, let's talk about some tips and best practices. Use variables instead of hard-coding values for flexibility. Changes to a parent affect its children, so plan hierarchies carefully. Keeping scales normalized avoids physics issues. Mastering the transform component helps you control movement, rotation, and scaling easily. Thanks for joining today's tutorial. If you found this guide helpful, be sure to like and subscribe for more Unity tutorials. Stay tuned for our next video.